Today's topic is noise, and for something that's usually pretty small, it's a very big topic when it comes to getting the highest quality test data possible. Hi, I'm Mike Beckage, co-founder of DTS, and today we're going to talk about noise. Let's start with what noise really is. When you're making measurements, you're generally trying to quantify the physical world using a variety of sensors. Sensors, data acquisition systems, and even the environment you're working in all create noise in the data. Noise is a normal part of making measurements, but sometimes if it's not properly controlled, it can be a problem and actually distort the data that you're trying to capture. Noise can be described as fluctuations superimposed on the signal you care about. These fluctuations can be caused by a number of different noise sources, specifically 5 we will focus on in this video. The first noise source is called Schottky or Schott noise. Schott noise is actually caused by random movement of electrons in conductors and semiconductors and even cables. This is something that is an inherent property of material, and there's really not much you can do about it. But even a simple wire or a basic transducer will have some Schott noise, which is just tiny signals that are superimposed on the data you care about. The second type of common noise in data acquisition is actually the noise that's inherent in complex electronic systems. This is noise that comes from the semiconductor amplifiers and other chips that are used in the system. It comes from the sensing elements themselves. And there's really not a lot you can do about that noise that's inherent to the system other than be aware that it's there. Its contribution is usually negligible, and you can even filter some of it out after you've collected the data. The third type of noise is actually something that we have great control over. When we assemble a data acquisition system, we're usually using a sensor of some type, like this strain gauge, and a data acquisition system. And these sensors and data acquisition systems will be installed in some test environment. Most test environments have all kinds of electromagnetic noise right in the air caused by the power supply systems in the building you're working in, or maybe even control systems and lighting systems or imagers on the testing system itself. The fourth potential noise source has to do with mounting the transducers. Transducers need to be placed appropriately and fully tightened according to manufacturer specifications in order to avoid noise that's simply caused by sensor mounting concerns. The fifth potential noise source has to do with the design of the sensors themselves. Some sensors have undamped sensing elements and can resonate at very high amplitudes and frequencies. Other sensors are damped internally to stop such internal vibrations. It's important to choose the right sensor for the job in order to avoid noise that comes from sensor resonance. How do we quantify noise? There are a couple of common ways of doing so, and one method is to have a function that describes the amplitude versus the frequency, typically referred to as noise per root hertz. A simpler way, which is the way we do it in our software at DTS, is to simply express the noise as a percentage of the measurement range. In that case, we typically want to see noise levels significantly less than 1%. Now that we've discussed the potential noise sources and how we quantify that noise, let's talk about some things we can do to minimize noise and improve the quality of your data. Some types of noise you just have to live with. The physics are the physics, and you can't stop Schott noise or even the electronics noise inside of semiconductor chips. Let's talk about some things that you can control. First of these is mounting considerations. Please follow the manufacturer's recommended mounting practices for all sensors that you're using in a test. The next thing you can do is carefully choose sensors for a given job. And what that means is look at the noise specs carefully, see what the levels are over the bandwidth you care about, and also pay attention to the resonance characteristics of the sensor to make sure it is compatible with the testing job. For noise that you simply can't avoid, you can always use a low-pass filter on the data once it's been collected to pass the bandwidth you care about but eliminate the higher frequency noise that you don't care about. I've saved the best for last. The number one thing you can do to control noise in test data is to make sure that the sensors, the test article, the data acquisition systems, and really any machinery in the test are properly grounded. This also includes using sensor cables that are properly shielded and, wherever possible, having an appropriate earth ground to bleed away either electrostatic or environmental noise from your test. I hope this information about noise has been helpful. For a number of the topics presented here today, there's more comprehensive information available on our Help Center. Happy testing!